Vitamin C does far more than stop your teeth from falling out or help you recover from a seasonal cold. Inside the body, it acts as a primary structural stabilizer, keeping blood vessels flexible and protecting arterial linings from toxic damage. Look at these particles side by side. Left is standard LVL cholesterol. Right is its genetic cousin, LPA, which you inherit at birth with no existing treatments to lower it. The difference is this extra protein tail, apolipoprotein A, which actively promotes blood clots. Millions of people carry high levels of this particle without knowing it, waiting for a pharmaceutical solution that is still years away from hitting the market. The existence of this dangerous particle is actually a remnant of human evolutionary history. Roughly 40 million years ago, our ancestors underwent an abrupt mutation in the GLO gene. This event disabled our ability to synthesize vitamin C internally, a trait most other mammals still possess. Without internal vitamin C, the risk of fatal bleeding from minor injuries increased dramatically. Evolution required a biological substitute to ensure the blood could still clot effectively. LPA appears to have evolved as that emergency backup. In 1990, Nobel laureate Linus Pauling and Dr. Rath proposed that modern heart disease is directly linked to this ancient deficiency. They argued that LPA is a surrogate for vitamin C. They proved this by studying the handful of mammals, like the European hedgehog, that also cannot make vitamin C. When these animals are deprived of the nutrient, their arteries fill with plaques loaded with LPA. Restoring the vitamin prevents the blockages from forming. Elevated LPA is an ancient biological survival mechanism, a stopgap measure for an environment where vitamin C was scarce. Deactivating it requires a specific nutritional intervention. We can see how this disarmament works by looking at the microscopic environment inside the artery wall. Heart disease begins when LDL cholesterol becomes damaged by oxidation and turns toxic. This oxidized LDL kills the smooth muscle cells that line your blood vessels, creating the foundation for dangerous plaques. In clinical trials, 500 milligrams of vitamin C daily produced an 18% reduction in this toxic oxidized fraction. While total cholesterol levels stayed the same, the actual damage to the artery walls decreased. Vitamin C also stabilizes a critical cofactor called BH4, which is necessary for the production of nitric oxide. Increased nitric oxide allows the blood vessels to flex and expand. This improves blood flow and prevents the friction that leads to arterial damage. By shielding the cholesterol from oxidation and widening the vessels, vitamin C removes the conditions that allow LPA to take hold. LPA physically grabs onto blood clots using molecular ledges called lysine binding sites. Vitamin C activates an enzyme altering the artery's collagen, smoothing out these ledges, making the wall too slippery for LPA to maintain grip. You can amplify this effect by introducing the amino acid lysine into the protocol. Supplementing with lysine floods the bloodstream with molecular decoys. The LPA particles grab onto these free-floating decoys instead of the artery wall, allowing them to be washed away harmlessly. This combination also lowers IL-6, an inflammatory molecule that signals your liver to produce more LPA in the first place. By smoothing the arterial surface and deploying molecular decoys, you can physically disarm a genetic risk factor that was once considered unreachable. The government's recommended dietary allowance for vitamin C is designed to prevent acute disease like scurvy, not to optimize your cardiovascular health. A more effective protocol involves 1,000 milligrams of vitamin C daily, split into 2 doses to maintain stable levels in the blood. This is paired with 2 grams of lysine. You should also prioritize whole food sources. Red bell peppers, broccoli, and strawberries provide the highest concentrations of vitamin C per serving. Nutritionist Ray Peat also suggested using fresh squeezed orange juice. In his framework, the natural fruit sugars support thyroid function and metabolic rate, providing a protective environment for the heart. This strategy requires caution. While orange juice can support those with a healthy metabolism, the high sugar content can be problematic for anyone with insulin resistance. Success depends on balancing these high-dose nutrients with a diet that respects your specific metabolic limits. To know if the protocol is working, you have to track the biomarkers in your blood. Before starting, establish a baseline for 3 specific markers: total LPA, oxidized LDL, and the inflammatory signal IL-6. Follow the protocol for 3 to 6 months and then retest. You are looking for clear reductions in oxidation and inflammation. Your absolute LPA number may not drop significantly, but that is secondary. The real victory is making the particle less sticky and lowering the inflammation that allows it to build up. By using these specific molecular mechanisms to smooth your arteries and flood your system with decoys, you can neutralize a risk factor that medicine once considered untreatable.